In the summer of 2023, the University of California published a study generating global headlines, claiming older adults experienced a staggering 226% memory improvement. The intervention that triggered this media frenzy required no intense cognitive training or complex drug regimens. Participants simply turned on a room diffuser for 2 hours every night as they fell asleep. They rotated through a specific sequence of 7 common essential oils: rose, orange, eucalyptus, lemon, peppermint, rosemary, and lavender, 1 scent per night. This completely passive routine was sustained uninterrupted for 6 full months. The medical stakes behind this test are high. As humans age, the deterioration of the olfactory system, the ability to smell, is often the very first symptom of Alzheimer's disease and broader cognitive decline. If the study's conclusions held up, researchers had found a zero-effort, non-invasive method to halt or even reverse the physical deterioration of the aging brain. To determine if that 226% figure is a genuine medical miracle or a statistical mirage, we have to strip away the university PR and look closely at the raw data. Mapping the sensory routing system explains why a diffuser could affect memory. Vision, hearing, and touch don't have direct lines to higher cognitive functions. They pass through a central hub, the thalamus. It acts as an internal switchboard, sorting inputs before routing them onward. The physical journey of an odorant molecule follows completely different rules. When a scent enters the nasal cavity, it interacts directly with the olfactory nerve. As our shortest cranial nerve, it provides the most direct physical access from the outside world into the brain. Because of this unique anatomy, the olfactory nerve bypasses the thalamus switchboard entirely. Instead, it routes its signal directly into the limbic system, the biological epicenter for both emotion and memory formation. This anatomical bypass is what researchers call the olfactory superhighway, explaining the study's underlying physiological mechanism. Scent is the only sense that can passively stimulate the brain's memory centers while the rest of the body sleeps. To see if this overnight stimulation actually worked, the researchers focused their imaging on a specific anatomical target located deep within the limbic system. This target is the left uncinate fasciculus. The uncinate fasciculus is a major white matter pathway linking the amygdala to the prefrontal cortex. It plays a crucial role in episodic memory and language processing. In healthy humans, this pathway naturally degrades with age. In patients with Alzheimer's disease, it deteriorates severely. To map the health of this specific pathway over the 6-month trial, researchers used diffusion tensor imaging, or DTI. DTI scans track the movement of water molecules inside the brain's white matter tracts. By analyzing this flow, researchers calculate mean diffusivity. When water moves in a highly restricted, linear pattern, it indicates a healthy, robust tract. After 6 months of nightly essential oil diffusion, the fMRI scans confirmed that the enriched group showed modified, improved mean diffusivity in the left uncinate fasciculus. This is physical proof of structural neuroplasticity. The brains of the older adults in the enriched group physically changed their wiring in response to the overnight sense. Proving a physical change in the brain is a significant scientific achievement, but a localized structural improvement does not automatically translate to a 226% cognitive upgrade in a patient's daily life. To understand the 226% claim, we have to look past the objective brain scans and examine the behavioral cognitive assessment data. The researchers measured memory using the Ray Auditory Verbal Learning Test. The mechanics are straightforward. A researcher reads a list of 15 words, and the participant must immediately recall as many as possible. To test learning capacity and retention, this 15-word recall process is repeated across 5 consecutive trials. The baseline behavioral findings were surprisingly flat. There were absolutely 0 significant differences in working memory, planning, or attention switching between the control group and the scent-enriched group. Even on the word recall test, across the first 4 trials, the enriched group showed no major advantage. The massive 226% improvement cited in the headlines is isolated solely to the 5th and final recall trial. But the execution of this trial was interrupted by a massive external factor, the outbreak of the COVID-19 pandemic. The pandemic forced researchers to alter their methodology. They had to switch from controlled in-office baseline testing to remote testing conducted via video conferencing in the participants' homes. To maintain the integrity of the data, the researchers made the correct, but costly, decision to exclude any participant whose testing conditions were compromised by the lockdown shift. As a result, the initial pool of 43 participants was slashed down. Only 23 valid participants remained to be analyzed for the cognitive assessment. The study's 226% memory improvement rests entirely on a single data point from the 5th trial of one test drawn from a severely reduced pool of people. Let's break down the actual performance of the 12 participants in the enriched group on that crucial 5th recall trial. Out of those 12 enriched participants, exactly half, only 6 people, actually improved their score from the baseline. Within that same group, 5 stayed exactly the same, and 1 actually performed worse. Now look at the 11 participants comprising the control group. In the control group, 3 participants improved their score, and 1 stayed the same. But here is the data point that skews the entire calculation. 7 of the 11 control participants performed significantly worse. This chart, published in the peer-reviewed study, shows the mean difference between these two groups. The math is clear. The control group's mean score plunged into the negative, while the enriched groups grew modestly. The 226% figure is a relative calculation. It measures the vast gap between the control group's steep loss and the enriched group's mild gain. The headline number is mathematically accurate, but contextually misleading. The high percentage relies heavily on the control group's failure, rather than demonstrating a superhuman cognitive surge in the enriched group. The university's PR machinery engineered a headline to go viral by weaponizing relative statistics. But dismissing the intervention entirely because of marketing would mean ignoring a genuine scientific finding. The fMRI data remains undeniable. The simple act of smelling essential oils successfully and physically modified the left uncinate fasciculus in older adults. This structural brain change was achieved with zero conscious effort, relying entirely on passive environmental enrichment. Other cognitive interventions require intensive puzzle regimens or rigid sniff training protocols that demand high patient compliance. This required turning on a diffuser at bedtime. Modern science requires us to rigorously interrogate viral statistics, but the proven ability to passively use the brain's olfactory bypass to fight physical deterioration remains a profound and valid scientific victory.